Alright guys, welcome back to the show. Glad you came back. I really do think if you pay some attention to this, you will get something out of it. Hopefully remind you of something you may have forgotten, or teach you something you never knew in the first place. Remember, this test is 20% of your overall grade for the year, so it's worth a lot of points. You don't want to completely bomb it. Alright, let's look at number 25. We did 1 through 24 yesterday. We'll do most of 25 through 48 today. We may skip around a little bit. Which equation corresponds to the graph below? That's an easy one, I hope. Let's go over here and look at our graph. Where does the graph cross the y-intercept? At 2. So we know in the form y equals mx plus b, this y-intercept is negative, I said positive, sorry, is negative 2. Can't I stop right there? This is the only equation that has negative 2 as the y-intercept. But let's just check to make sure. Does it also have 1 as my slope? Is my slope 1? Well, up 1 over 1, I'm back on the graph. Up 1 over 1, so yes. My slope is 1. C is the right answer. Alright, turn the page. Number 26, golly gee, probably the easiest problem on the page. It says, based on the two tables, what common point do these two equations share? All we're doing is looking for a common point. I have 2, 3, I have 2, 3, 2, 3 is the common point, C. Number 27. The first term in this sequence is negative 1. Well, there I see it, negative 1. My second term is 2, my third term is 3, and so on and so on. Which function represents the sequence? Well, this is an easy plug-in. I'm going to check to see if I plug in 1 for my n values. Do I get negative 1? Well, when I plug it in here, 1 plus 1 is 2. That's not negative 1. On B, 1 plus 2 is 3. That's not negative 1. 2 times 1 is 2. 2 minus 1 equals 1. That's not negative 1, so the answer I bet has to be D. 2 times 1 is 2, minus 3 is indeed negative 1. Ding, 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 winner, winner, chicken dinner. D is the right answer. Well, a minute ago I said 26 was probably the easiest item on the test. 28 is right behind it in ease, if you understand what they're asking. It says, if f of 9 equals 4 times 9 minus x, which function gives f of x? All you have to do is substitute in x whenever you see 9. So that would just be f of x equals 4x minus 12. Simply substituting in x here and x here. Answer is C. Number 29. A farmer owns a horse that can continuously run at an average of 8 miles an hour for up to 7 hours. Let y be the distance the horse can travel. So this would be our y. Distance horse travel, 8 miles an hour. And x be the amount of time in hours. So x up to 7 hours. The horse's progress can be modeled by a function. Which function describes the domain? Well, remember we have domain and we have range. The domain are the x values. The range are the y values. So we're only talking about the x values. So we're only talking about this time component. Up to 7, what does that mean? That means 7 or between 7 and 0 can be x. Does one of these say that? There it is. X is between 7 and 0. Done. A. Number 30. A population of squirrels doubles every year. Initially, there were 5 squirrels. A marine biologist studying, not a marine biologist, sorry, just a biologist. It'd be strange for a marine biologist to be studying squirrels. Anyway, back to the problem. A biologist studying the squirrels created a function to model their population growth. P of t equals 5 times 2t, where t is the time. The graph of the function is shown. What is the valid range of the function if it is to correctly model the population? Well, this is the graph of 5 times 2 to the t power. But this is a real world problem. And where do we start this real world problem? 5. There were 5 squirrels. 5 squirrels. So the range, remember that's the y values, have to start at 5, right here. So our graph really should go only here and up. We started at 5. You can't have this negative time, so we can only have positive time. So right here, the graph has to start at 5. The range, the y values, can be any whole number greater than 5. Number 31. The function graphed on this coordinate grid models the maximum height, y, of a ball dropped in feet after its xth bounce. So what does this mean? We start up here at the number of bounces. We have no bounces. We're up at 25 feet. So that's where we're dropping the ball from. At one bounce, how high does it go? 10 feet. The second bounce looks like about 4 feet. Third bounce looks like about 2 feet. And the fourth bounce, it looks like about 1 foot. So what does this say? On which bounce was the height of the ball approximately 4 feet? Well, it's right there. The second bounce, he was at about 4 feet. So bounce number 2, B, is the right answer. Number 32, renting a canoe. To rent a canoe, the cost is $3 for the oars and the life preserver, plus $5 an hour for the canoe. Which graph models the cost of renting a canoe? Well, I got several kinds of functions here. This one, you've never seen a function like this. This is actually a log function. These two are straight lines, so they are linear and linear. This one, curves going up more steeply, that's an exponential. So I need to know if this is, can't be log. We've never talked about logs. We don't go over logs in this class. You've never seen that kind of graph. What we need to know is this linear or is this exponential? Well, how would I write the equation for this? It costs $3 for the oars and life preservers. So let's say y equals 3 plus $5 an hour plus 5 times x. Now, is that exponential? No. To be exponential, we have to have something to the x power. I don't have a power of x here, so these are both just straight lines. And in fact, if you turn these two things around, you have 5x plus 3. You can see it's a line in slope-intercept form. Here's the y-intercept. What's the y-intercept of this line? 3. Which one of these two has a y-intercept of 3? Not that one. That's right at about 5. This one is down closer to 3. So my answer is C. It's a linear function, and it has a y-intercept of about 3. So that's how we would do that problem. Number 33. Juan and Patty decided to see who could read the most books in a month. They began to keep track after Patty had already read 5 books. So this is Patty. She's already read 5 books here. This is her graph. The graph shows the number of books Patty read for the next 10 days. So by day 4, she was up to 10 books. By day 8, she was up to 15 books, and so on. If Juan has read no books before the 4th day of the month, and he reads at the same rate as Patty, how many books will he have read by day 8? So he's starting at 0. 0 books on day 4. And he wants to go the same rate as Patty. What is Patty's rate? Another word for rate is slope. Remember, slope is the rise over run. So we want the same rise over run. Well, what is Patty's rise over run? Well, here we have a good point, and here we have a good point. A rise of 1, a run of 2. 1 over 2. So if I go 1 over 2, and 1 over 2, and 1 over 2, I will have Juan's line. It will look something like that. And now we can answer the question, how many books will he have read by day 8? Day 8, right here, ding, 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 5 books. The answer is A, 5 books. If the points 0, 1, 1, 4, 216, 364 are on the graph of a function, which represents that function? It's either 2 to the x power, 3 to the x power, 4 to the x power, or 5 to the x power. I think this is easier if we put it in a little xy table so we can see what's happening. 0, 1, 2, 3. This is 1, 4, 16, 64. So are these going up with powers of 2 or 3 or 4 or 5? Well, this is my first term. I go from 1 to 4 to 16 to 64. So I know that that is 4 to the first power, 4 to the second power, 4 to the third power, and even 1 would be 4 to the 0 power. So it's going up f of x equals 4 to the x power. You couldn't get here 5 to any power to be 4. 2 to any power could be 2, but then it gets messed up as we go down, and it couldn't be 3. So C, f of x equals 4 to the x power. Number 35 is a scatter plot. It says, which scatter plot represents a model of exponential growth? Exponential growth. Well, let's see what these models look like. This one looks a lot like a straight line. This one looks a lot like a straight line headed in that direction. This looks like a straight line, just kind of a mess, headed off maybe in this direction. This is the only one that shows an exponential curve. Remember, an exponential curve looks like this. Starts and it goes more steep, more steep, more steep. That looks like that. That's an exponential. We have 3 types of things we've studied. We've studied exponentials. We've studied quadratics. Quadratics look like that. And that's a quadratic. And we've studied linear. Linear simply is a straight line. So this is my exponential. I start, I curve, I'm getting steeper and steeper and steeper, going that direction. That one is obviously an exponential. So in the years since 2000, the deer population has gone up exponentially. deer has 4 babies, their baby has 4 babies, their baby has 4 babies, and all of a sudden we have a lot of deer. Alright, I'm going to skip over number 36, because I don't think number 36 is that important with these functions. Number 37. We have to remember our shapes of our distributions. Let me remind you what our 4 shapes look like. I'm going to go ahead and tell you right now. Well, let's look at them. Symmetric. A symmetric distribution looks like a bell shape. That's symmetric. Does this look bell-shaped? No. It's got a long tail off this side. A uniform distribution means it's the same for the whole time. So it's a flat line. That's a uniform distribution. So this distribution is skewed. Is it skewed left or is it skewed right? Well, here we go. It's skewed left. A skewed left distribution looks like this. We have a long left-hand tail, and then it goes like that. So this is skewed left with a long left tail. Skewed right would look like this, where we have short end here, and then we have a long right-hand tail. So that's skewed right. So this one is skewed to the left. Skewed to the left. The answer is C. Number 38. The data below are final exam scores of 10 randomly selected students and the number of hours they studied for each exam. Determine the linear regression equation that best fits the data. Determine the linear regression equation that best fits the data. Let me turn to that on my paper here. Alright, we did linear regression earlier in the year. And what regression does, when we run regression on our graphing calculators, we have the equation y equals ax plus b. Regression will tell us what a is and will tell us what b is. So I've got to go look for the regression, find out what my a value is, what my b value is, then I'll be able to know which of these equations fits the data the best. So I've got to go put this data in my calculator. If you remember, this is the x value. I'll put this in list 1. This is my y value. I'll put this in list 2. Then we're going to run regression. So let's go look at how we do that again. Pull up my calculator here. Where are we? There's the calculator. Alright, we go to Stat, this button right here, almost in the middle. Then hit Enter for Edit. And we will see list 1 through list 6. So I want to put my x values in list 1. So let's put them in there. 3. Enter. 5. Enter. 2. Enter. 8. Enter. 2. Enter. 4. Enter. 4. Enter. 5. Enter. 6. Enter. 3. Enter. So there are my 10 values for list 1. I hit my right arrow button to go over to list 2. Now I'll put in the list 2 values. 65, 80, 60, 88, 66, 78, 85, 90, 90, 71. And there I have my 10 values in list 2. So now to run the regression, let me remind you how to do that. Clear off my phone so it stops yapping at me. So we go Stat, Calc for calculating, and you see right here number 4, linear regression a plus bx. We're going to run the linear regression a plus bx. We do that, we go to 4, we hit Enter. There we go. It shows me clearly I have an a value of 5.04 and a b value of 5611. So an a 5.04, a b value of 5611. Look back at our paper, which one goes with that? That's right, it's C. So there's my equation. Y equals 5.04x plus 5611. Okay, good. Let's look at number 39. We did not do residual plots. That's not one of the standards, so we're going to skip 39. All right, number 40, using a two-way frequency table. Two ways, that means up top here, you have one variable. I guess this is the foreign language enrollment at this high school. And over here we have another variable, and that's gender, male or female. Determine which statement is true. There are more students enrolled in Spanish than French and German combined. Well, is that true? There's 88 in Spanish. French plus German, 48 plus 41 is 89, so that's not true. There are more in French and German. So, not that one. There are more females taking Spanish. Females taking Spanish, 46. Than the total number of students taking German. German total, 41. Ding, ding, ding. We have a right answer. B. There are more females taking Spanish than the total number of students taking German. All right, let's go to question 41. Using the frequency table below, out of all the women in the sample, determine what percent of women live off campus. Well, where is my total women? Right here. Women total. There's 7,582 women. So out of these women, what percent live off campus? That's on campus, here's off campus. So we have a simple division here. 3758 out of 7582. 3758 out of 7582. We do that division and you will get B, 49.6%. 49.6%. All right, we're doing well. Here we go, number 42. We got some graphs. It says Bob played a game 40 times, and the number of points he scored in each game are listed below. Which represents the values, which representation of the data values below is correct? Well, you see that I have a 5. And then I have a gap. There's no 6s and no 7s. I have 8s, 9s, 10s, 11s, 12s, 13s, 14s, 15s. So which graph below has a gap between 5 and 8? Which has a gap between 5 and 8? Easy to see, right? Right there. This dot plot. No values for 6, no values for 7. Both of these have values in the 6-7 range, values in the 6-7 range here. So A is our hopefully fairly obvious answer. The graph to the right shows a scatter plot and the associated linear regression. So there's a line of best fit on here. That line of best fit has this equation. Shows it right there. Associated with linear regression of a sample of 10 students' measurements. Their height versus their shoe size. So the height in feet is on the bottom here. The shoe size is on the side. What it's saying here with this line that's going up is that in general, person's height, the bigger the height is, the taller the person is, the larger their shoe size. Now we all know people who are short and have big feet, but that's really rare. Generally, short people have shorter feet, taller people have larger feet. It's asked the question, using the linear regression model, predict the height of a person who wears a size 11 shoe. Size 11. Well, where is size 11? Right here. So let's go over this way, and we meet the line right there. Come straight down. Where are we? We're almost exactly at 6 feet. Size 11 shoe, 6 foot. Ding, ding, ding. We have a winner. Alright, number 44. What would be the most likely correlation coefficient, R, for the following scatter plot? Well, we learned about R values, and R values have to do with how close the points are to a line. So let's draw a line through this data. Line through the data might look something like that, about an equal number of points above and below the line, so something like that. So there's our line. So the first thing we need to talk about is its slope. Is this sloped up or is this sloped down? Well, as we go from left to right, it goes down, so that's a negative slope. Negative slope equals negative R value. So which of these have negative R values? C and D. So it's either C or D. Now we just have to look at the numbers. We have 0.351 and 0.913. Here's what you have to remember. The closer the R value comes to 1, the closer the values are to the line. When the R equals 1, it's a perfectly straight line with your data points. When R equals 0, it's a big mess, stuff everywhere. So, which would it be? Would this be 0.913, which is close to that 1 value? Or would it be 0.351, which is closer to that 0 value? Obviously, I hope you said D. Negative 0.913. Negative, meaning the slope goes down. 0.913, meaning all the data points are close to the line. So there it is. All right, we don't need to do 45. We don't need to do 46. We can do 47. Let's do 47. A reading teacher recorded the number of pages read in an hour by each of her students. The numbers are shown below. For this data, which summary statistic is not correct? Not correct. Well, you have to remember how we got our summary statistics, how we got our quartiles and median and max and min. We did this fancy thing in the computer. I'm sorry, not the computer, the calculator. Let me remind you how to do that. So let's get back to our calculator here. Clear this out. And I'm going to go ahead and reset my calculator. Second plus 7, 1, 2. So everything will be neat and tidy like I want it to be. Turn my page to where the data is. Alright, now I have to go put the data in the calculator. And remember, the way we put the data in the calculator is we go to Stat, and we go to Edit. So now I've got clean lists because I cleared the calculator. Let's put all our data into list 1. So here we go. 44, enter, 49, enter, 39, enter, 43, enter, 50, enter, 44, enter, 45, enter, 49, enter, 51, enter. So 9 pieces of data, yes, 9 pieces of data. So there we have it. Once you have the data in the calculator, the way to find out all the good stuff about that data set is to run, if you remember, what's called 1 var stats. It stands for 1 variable statistics. So we're going to get all the statistics on this data set. Here's how we do it. We hit stat again. We go to calculate, so right arrow over, and you'll see the top one here. The top one says 1 var stats. So we're just going to hit enter at 1 var stats. Hit enter again. Well, we see some stuff. We see X bar. Well, that's an average. It doesn't ask us anything about the average. It asks us about minimum, lower quartile, median, maximum. Nothing is on the screen. Oh, but we see this little arrow down here. It means there's more stuff down below, folks. Press arrow down. Look what we've come up with. The minimum, the first quartile, the median, the third quartile, and the maximum. So let's see what's not correct. A says the minimum is 39. Well, that's true. The minimum is 39. B says the lower quartile is 44. No, the lower quartile is 43.5. That does not equal 44. So we think it's B. Let's check the others. The median is 45. There it is, MED 45. Maximum of 51. So these three check out. This is B. B does not check out. So, oops. I've lost myself here. Pull this back up. So B is the right answer. Okay, and we're not going to go over 48 either. That's an overly confusing question that I think I would just confuse you more by talking about it. Hopefully you got something out of today. Hopefully this helps you understand a little more about what's going to be on the test. Thank you very much. Later.